Hello, AP Stat students, and welcome back. This is chapter 19. Okay, this is the very first video lesson that I've done here. Okay, you want to listen to the video as closely as you can. It's always wise to go back, maybe listen to it again if you didn't get the first time. And you can always supplement this video with some other YouTube videos or any other resources that you can find. Today I'm going to be talking about chapter 19, which we get into this idea of hypothesis and hypothesis testing. Okay, so we really like to test hypotheses, something that we do all the time. Okay, we make a claim in science, okay, in real life we make some type of claim, and then that claim has to hold up to tests. Okay, and this is a statistical type of test. Okay. So what we've done before is we did this already, confidence intervals, where we kind of started to get into this idea of, oh, okay, if a value maybe doesn't fall inside of there, maybe it's a little weird. Okay, so a confidence interval helped us, okay, to start this journey. But now we get into these hypothesis or significance tests. Sometimes you'll hear them called significance test. And the big thing with the significant test, okay, is you get to this statistical significance. You hear it all the time, okay? And it's going to assess the evidence for a claim, okay, about a parameter. Basically, when I make a sample, when I draw a sample, does it give me strong evidence to support my claim? Or is that just, or did I get a weird sample just by happenstance? Okay. If it gives me evidence to support the claim, so basically it falls inside the realm of my beliefs, I feel good about it. Or if I think that, oh, this is just one of those weird cases. Sometimes we're not going to get it, right? We have our normal model, right? And we've kind of talked about this before. We have this 95% confidence interval that we've created in here. And if we were to get samples that were anywhere inside of here, we would feel pretty good. Well, this idea of this sample due to natural sampling variability, there will be some sample that sits out here, right? There's naturally going to be something that sits out there at least one time, right? Or on the low side, okay? Now, it shouldn't happen a lot. And that is where we get into this whole piece or this whole idea about sufficient evidence. Okay. So again, in statistics, it's a hypothesis, okay? It's something about the real world, right? We make some kind of claim, okay? And then we sample. And we hope that the data that we collect is consistent. We hope the data is consistent with the model that we chose, okay? We do not disbelieve or not trust our hypothesis. I've talked about this many times, okay? We believe when we sampled that we did everything we were supposed to, right? We weren't biased or anything like that, so we believe our results. Thus, we should believe our hypothesis at the start until we collect data to disprove that, okay? Now, we talk often in stats about this idea of lend support to the hypothesis, okay? That means, hey, I collected some data, and I think that that backs me up. But this is where a lot of people get caught, okay? People mainly that have never taken stats. You do not prove a claim based on one sample. All you do is you collect data to back that up, okay? You're only collecting data to back up your hypothesis, okay, but you can't, in fact, prove it. Now, of course, this doubles back. Well, if you get data that's not consistent, okay, with the model, then we have to make this kind of huge choice as to, okay, did I just get a bad piece of data, or is the data so crazy that I have to reject my model? Okay. And of course, we have percentages and we have a numerical value to assign this to, so it's not just some guesswork. So we get into this general outline for hypothesis test. I don't need to go into a great deal of depth here, but you do need to write a set, keyword a set, of hypotheses. We have this HO, okay? We have the HO and we have HA. Typically, I will write HA with a capital A, okay? HO is known as the null hypothesis, okay? H null, you'll hear it say H naught, okay? This right here can be said as H naught, okay? And it is what is assumed to be true, okay? Basically, this is my hypothesis, or somebody told me that this was the percentage, or somebody told me that this was the height of something, or the weight of something, okay? It is the assumed, it is the accepted, okay? It is the accepted norm. Now, of course, this is due with like no change in the population parameter, all right? And typically the way we write it, you know, if we're talking about, we've been talking about P's, right? So population proportions, prop, which of course, that's why I have this P here, okay? We'll get into some other ones later, okay? But when we write this, we'll write P equals, and the key thing to remember here, I have it written down here in your notes, is it's always an equal sign, okay? It is always an equal sign in the H null. Then our alternative is what you're trying to prove. So, okay, I tell you that, you know, the percentage of people that love mathematics is 17% of Americans, okay? Oh, and then you make the claim, no, I think it's more than 17. Oh, all right, so you say, no, I think it's more than 17. So in that quick example I just gave, I told you the accepted was 17% of people like math. Oh, then H sub A would be, well, you say, no way, people have to like math more than that. So it's got to be greater than 17%. Okay, this would be what is assumed. And then down here is what you would like to prove. This is what you would like to prove. Essentially meaning that you would like to disprove the null. All right. And of course, that's only one quick example where I wanted something greater than out of that. So you could have less thans. Like, so if you really hated math, maybe you fell into the category, well, oh, I think that this actually should be P is less than 17. There's no way 17% of people like math. Okay. Or you could fall into the category, well, hey, I just actually don't believe you. I don't know if it's better or worse than that, but I actually just don't believe you saying it's 17%, which we can do that too. Okay. And of course, when I'm talking about this quick example I just made up, right? I just completely made this one up randomly. If we go back to what I had down originally, let's see if I can erase some of this. So I originally had down this right here, right? Well, would this be enough if I just told you to write the hypothesis? Think about it. Well, as you're reading this, if you would just had this and that was it, you'd be confused, right? You would be confused. You don't know what P is. So here I'd also have to say P is the prop of, I think I said Americans who like math. Okay, and now I've written a hypothesis test, okay, or at least the start of one. All right, well, I think now we're ready to actually try to conquer the example sheet. All right, so take out your examples. Now would be a great time to pause this video. Super great time, pause this video, read number 1, and then try it. Okay. All right, now that you've had a chance to pause the video and try out number 1, I'll read it here together, or I guess I'll read it out loud. Write the null and alternative hypotheses you would use to test the following situation. A governor is concerned about his negatives, the percentage of state residents who express disapproval of his job performance. His political committee pays for a series of TV ads, hoping that they can keep the negatives below 30. They will use follow-up polling to assess the ads' effectiveness. Okay, so this doesn't seem all that bad. Some key things that we'll probably want to grab out, right? Right away, this should hit you, right? It says 30%, and they're running some ads, right? They're going to run some ads, and they're hoping that they can get it, oh, not just 30% there, but below 30. Okay, so let's think about what they would like to have this ad campaign do. Well, it sounds like they would like the ad campaign to be below 30%. Okay, well, what's below 30%? Oh, okay, that's my P. My P would be the population proportion of voters who disapprove of, well, what was his name? Oh, it doesn't even say the governor, who disapprove of the governor. Okay, so this is a good start. Well, right now, okay, we said that we want to get this thing below 30. Okay, well, then that means right now we actually believe that it's at 30. Okay, we believe right now that it's at 30%. And now I would like to get that sucker, right? I'd like to get it below 30. Okay, well, below 30% would be less than 30%. It is not important here with the proportion to actually hit the equal to on the bottom. Okay, you can. It's not a big deal here. And then we've done our very first one. Okay. At this point, I would again pause the video. I'd be pausing this video, and I would be trying number 2 out on my own. Okay, now that you've had a chance to try that one out on your own, all right, maybe I'll read it again here. Write the null hypothesis and alternatives. Okay, it sounds like the same thing there. Only about 20% of people who try to quit smoking succeed. Sellers of a motivational tape claim that listening to the recorded messages can help people quit. Okay, well, let's see here. Again, this 20% seems like it's really popping out to me. We're trying to get people to stop smoking. Great, well, let's make sure we classify our parameter. So P is the prop of people who quit smoking, right? So that's how many people quit smoking. All right, well, what do we believe right now? Well, right now we believe that P is equal to about 20%, right? And I would like that number, if they listen to this video, my claim is that the proportion will become, well, I want something compared to 20. Well, 20% is who quits, right? It's quit. So I'd actually, if the message helps, that should actually be greater. Okay, it'd be greater than that. Okay, you have to be super careful with how the question's worded and what's the population. Because very easily on this one, I could switch it up and I could say the number of people who smoke, right? If this is the percentage of people who smoke, and then I'm getting random people to listen to the video or to listen to motivational, then I'd want the percentage of people who smoke to go down, okay? But because we're quitting here, we want it to go up. Again, great time to pause the video, go back, listen to what I said, okay, work your way through the problems. But those are the first 2 examples, so I'm ready to go back to the notes. If I can get there. Okay. So then we get into, or we continue in this general outline. First step was to write. Okay, so step 1 was write HO and HA, so the null and the alternative. Great. So then the second step looks like says from the data calculate a statistic that estimates the parameter. This, okay, a statistic. So basically I need to draw some samples. I need to collect a valuable statistics or a statistic that is going to estimate the parameter. Okay, so if we think about this, like this would be like a p hat for our p. After we do that, okay, we need to think or answer this main question right here. Maybe I'll try to highlight it here. Let's change my pen here. And we're trying to figure out, is the value of this statistic far from the parameter value stated by HO? So basically, I drew a sample. right? I drew a sample, I got a statistic. Is that statistic way different than what they told me it should be? Okay. I believe it to be something, right? They told me what to believe. I drew a sample, and then it either is decently close, or we think it's okay, or we think that it's really far away from H null and that H null is wrong. Okay. Here, I'm not going to go into this test of significance applet. You can find it on the site. I think maybe I'll just pull it up so you can see what it looks like real quick. Of course, I did that with the pen and now. Okay, if I pull this up just really quick, what this applet does is if you shoot some shots, like I'll shoot some shots here, okay, and as we're shooting, it's believed that this team, now the team shoots 80% together, shoots 80%. And this shooter that just shot, oh, they shot, what, 10 shots, and they hit 80%. Okay, so that's something like, that sounds okay. Okay, they hit 80%, great. Sounds pretty good, they should have. Well, that's only one shooter, right? So I could draw another shooter. And we'll let them shoot, right? We're shooting 10 of them. Now, the team is supposed to be at 80, but theirs was only 40. Does that mean I should instantly think that the 80% mark is wrong? Or did they just have a bad shot, like a bad 10 free throws? Or are they on the low end and there's somebody up here on the top end that's going to help out the average? These are all things that happen, okay? And I'll let you get to this site. It's connected to the class website. You can go there, okay, and you can mess around with it and see how many shooters you want to go through, or you can do a bunch of different shooters until you find the true, okay? So I'll let you do that on your own. Now, what we're getting to, all right, is you're going to find or calculate a statistic. Then you're going to find a p-value, okay, a p-value. This is not a proportion value. You're going to find a p-value, which is a probability versus a proportion. It's a probability, so maybe I should, let's see here. This p-value right here is a probability. This is a probability, okay? And it is quantifying how surprised we should be to see the result. Okay, the result is the stat, right? To see our statistic based on if the assumption was true, okay? If the assumption was true, it tells me the probability that I should get a statistic like I got. All right, so it's the probability that the observed statistic value could occur if the null were correct. And I think I'll just hit this part. The null was correct. Okay, you're going to need to remember that. We always assume, okay, that the null, which is HO, this thing right here, is true until we gather enough evidence to say otherwise. Okay, now, if the p-value, okay, or the p-value is the probability that the p-hat is on the tail, okay, it's on a tail. So when you look at this, right, we had these little tails sitting out over here, right, technically on both sides. Now, what happens is here we have our p, right, and then I just said a little bit ago that, oh, okay, we draw a statistic, right, p-hat. And now, normally, we want to see, oh, well, what's like the probability that it would be greater than that, right? Or we're trying to go less than that. What's this little area out here? So we'll get a percentage chance sitting out here. Now, we anticipate this percentage chance sitting out here to be rather big, right? Because, I mean, just think about it here. If we drew a curve, right? Normal curve here. P's right down the middle, right? Say we draw a statistic, right? We're drawing a statistic, a p-hat. Now, if this is supposed to be this p, right? If this p-value right here is true, which is what we believe, right? Then we anticipate our p hat, this p hat, to be decently close to it, right? We wouldn't assume this distance from here to here to be very big. Because this distance isn't very big, that leaves a lot of percent sitting on the tail. Okay, so we'd anticipate this percentage to be big, right? Which of course is, a relative term there, big. Now, if I were to move, right? So let me draw another one here. So P is down the middle, right? And I get a P hat sitting out over here. All of a sudden now, this is a tiny percentage, which I wouldn't anticipate. This P hat shouldn't be out here. This P hat shouldn't be out here. So as I keep creeping this line outward, okay, it becomes more and more unlikely to get that P hat. So if I get that sample, I should be more and more suspicious of my P, which is exactly what this line here is saying. The more unlikely the P is, the p-value, means that I'm gaining more evidence against HO. If I have a tiny percentage chance of drawing a singular sample, okay, that gives me that value, then I should be shocked, okay, that this assumed value is true. Okay, so then just some more things that we can talk about, right? It says it measures the strength of the evidence against HO. The smaller the p-value, the stronger the evidence, okay? It's because this is just great stuff right here, right? It's further away from the assumed value. If it's further away, we don't believe it as much. We don't believe the assumed value anyway, okay? Then it says how small p-value needs to be depends on the context. Okay, this always is just going to be up to, okay, the researcher, or sometimes this is up to the manufacturers, like what are they willing to accept, okay? Typically, I will be telling you, I'll be telling you the p-value to use, okay? And I think I'm ready to do example number 3. So we're back to our example sheet. Okay, again, you could just read number 3. Take a second, read number 3, okay, and then it gives you a p-value, I think. So then based on that, just try to conclude something. You don't have to write anything down, just think through the problem. Okay, now that you've had a chance for that, I'll read it out here. So after the political ad campaign described in number 1, okay, we talked about number 1 before. The pollsters check the governor's negatives. They test the hypothesis that the ads produce no change against their alternative, that the negatives are now below 30%. So they used our test that we used before, okay, and they find this p-value. Is it reasonable to conclude that the ads were effective? Okay, so here we have the probability of p hat being less than 30%. So this is the probability of p hat being less than 30% is 22%. Okay, 22%. Which, let's see if we can actually interpret what that p-value means. This means that there's a 22% chance that we get a p hat less than 30% due to natural sampling variability, which sometimes we do natural sampling variability like that. Okay, so I said 22% chance that we get a p hat less than 30% chance due to natural sampling variability, assuming that the population, okay, so the population parameter was equal to 30%, okay, or assuming HO is true, which again, we always do. Now, do we think that 22% is big or small? Well, when I think about 22%, that seems like a decent chance. Like 22, that's like 1 in 5, right? 1 in 5 that's just due to natural sampling variability. That's not very high, okay? In fact, usually what we do is we compare 22, or whatever we get for the p-value, to 5%, where, okay, this 22% is bigger than 5%. So, do I think that this idea of 30% is incorrect? Do I think that the ads helped at all? No. Or a better way to write it probably would be the ads were ineffective. Because I don't believe that the population proportion has changed from 30%. And those are all the examples that we have here, okay? I really think it's wise to maybe get on YouTube. You can listen to a couple different ways that people interpret the p-values and help you write the hypotheses, because this is a huge part, okay, of chapter 19. Next time, we're going to talk about actually how to set up and conduct the entire hypothesis test. For your assignment here, okay, your assignment. Oh, well, it looks like I forgot one thing in notes here. I think this is okay. I mean, I can go through this decently quick. I don't want to skip it completely. It says the significance level of a test is alpha. This is very true. We do use this all the time. This is like the bar at which we're setting. So we have to have some type of value. Before I put, like, I think on the screen I put big in quotations. Well, this allows us to quantify it a little bit more. Okay, this is the bar that we're testing everything at. So it's the probability we reject HO when HO is true. That means that we're proving guilty when really a person's innocent. Okay, it means we were wrong. All right, it is a fixed value. It is the p-value. Okay, it's used to compare the p-value. And then we get into this here, and this is why I didn't want to skip it. Okay, skip this page and just make you read it on your own. You need to absolutely know every single bit right in here. You need to. It has to happen. If the p-value is less than alpha, then you have to reject HO. Basically, once you get a p-value tiny, you're saying, wow, that's super unlikely that I got that. I don't think that HO is right. So I'm going to reject it, and I'm going to conclude HA. I will conclude HA. And when I do that, the reason I can conclude HA is because I've found something statistically significant to disprove, okay, HO. Now, on the flip side of that, if my p-value is greater than alpha, which is what we just had on example 3, right? On example 3, I think I had 22%, and I said the usual alpha value was 5%. Here, we fail to reject HO. It's not that we accept it. It's just that we failed to reject it. We couldn't disprove it, which means we still have to be okay with assuming that it's true, but we're not saying it's a fact. There is a huge difference here, okay? You cannot just blindly accept the null, okay? You just fail to reject it. So on our last example, I just failed to show the P was not even not. I just failed because what was it? It was less than. I failed to show that P was less than 30%. Okay, I did not prove that P was equal to 30. There's a huge difference there. Here's your assignment. Okay, of course you can do the reading. I do think it helps, especially since you have to do this lesson online. Okay, or you can just listen to the video, maybe supplement it with another YouTube video, okay, something else, get some help from a classmate, but you should be returning to class ready for a Frappy and a homework quiz. Okay, I'm available via email for any questions.